Okay, so our last video is going to be on adding and subtracting, multiplying and dividing rational functions. So just like regular functions, when we're adding and subtracting, we have to have common denominators. So let me give you a better example than that. So if I had like 2/4 plus a fourth, I'm just able to add and I get 3/4. I don't get 3/8. The denominator stays the same. Now if I'm multiplying or dividing, the denominators do not have to be the same. Okay, so since these ones are the same, they're both x plus 1, I can just add straight across and combine like terms. And I can get 2x plus 2 over x plus 1. Now there would be some credit taken off for this problem because it's not fully simplified. Before any problem finishes, I would want to, or starts, you could do it at the beginning too. I want to make sure that things are factored, because when I factor the top, you'll see this turns into that. Because these two, I can see, are divisible by 2. And now I can see that these go away, and the answer is 2. Okay, now we have one with unlike denominators. Good. So when this happens, we need to multiply by the opposite denominator. So I'm going to multiply the top and the bottom by x plus 2. Okay? And I'm going to multiply the other one by x minus 5. But before I do that, I just don't want this to get confused with what would happen if this was an equation. If this was an equation and I was multiplying by x plus 2, this would go away. I'd have times x plus 2 on the top, but I wouldn't repeat that on the bottom, okay? Because that wouldn't be multiplying by just x plus 2. If I multiply by the top and the bottom, that's like multiplying by 1, and I wouldn't want to do that here. It would change the value. So here, I am not changing the value, essentially, but I am giving them common denominators. So I'm multiplying by x plus 2, and I'm multiplying by x plus 2, and over here by x minus 5, and x minus 5. So now I'm going to multiply. I have common denominators, so let's go ahead and do a little bit of simplification. And let's multiply through. So here I would have 2x squared minus 10x. And over here I'd have to FOIL, and I would get x squared plus 2x minus x minus 2. And this is all over our common denominator, but I'll write that last. So I combine my x squareds to get this. And I would combine this and this to get, oh, and this, right? So I have negative 10, positive 2, negative 1. And that would leave me with, oh, actually, this was 3x squared, because it's 2x squared plus 1x squared, 3x squared. And then this one is going to be negative 9x. And then I'm going to have minus 2. And I'm going to put that over a common denominator of x minus 5, x plus 2. Now, factoring when a is not 1 is not going to be on this test. But if a was 1, you would want to factor it and make sure that any of the factors of the numerator weren't x minus 5 or x plus 2. Because if they were, you would then have a whole. But since this one is 3, that's as far as we're going to take it. 8. Okay, so you might want to try 8 on your own. Again, before you start these problems, you always want to try to factor. Factor anything you can. So we've been factoring like this, where you write 8 and 6, and it's what multiplies to 8 and adds to 6, which is 4 and 2. I'm not going to draw that out for every single one, okay? You might pause the video and test your factoring skills and make sure that you get them all right, okay? So that top left factors to x plus 4, x plus 2. And the top right, so the top left is that. The top right, let's see, that would be x plus 4, x minus 1. And then the bottom left would be x minus 1, x minus 4, and then this one is x plus 2 and x plus 2. Okay, so like I said, they don't have to have common denominators when it's multiplication. So essentially what this is this. And this is always my favorite part. I get to make the problem more simple by crossing things out. So those divide out. And what else divides out? This and this divide out. And we are left with x plus 4 squared, or you could write x plus 4 times x plus 4, over x minus 4 times x plus 2. Done. There it is. If you want to multiply these things out on top, you could, but you don't have to. All right, number 9. So again, we're going to factor. All those things can be factored. Try to factor them on your own. Pause the video, see if you get it right. Now, I am going to make this division multiplication and flip this, so don't get confused by that, okay? Okay, now I've made it a big multiplication problem. So when I multiply this together, what I do not want to do, and this is the biggest difference between addition and subtraction, is I don't want to start distributing things. Because my hope is that I can cross off things on the top and the bottom. If this was addition and these were like denominators, I would multiply them out and I would combine like terms. But since it is not, and it is multiplication, I would think of the top like this. Now you can see that some things are going to cancel and go away. So we're going to have this going away with this, and this, and this, leaving me with what? That would leave me with 4x over 5 times x minus 5. I could also rewrite this as 5x minus 25, but either way. Okay, 2 more. So again, here we are going to factor whenever we can. So I'm going to think of the bottom part as x plus 2, x minus 2, plus 4 over x plus 2. Okay, so these two almost have common denominators as they are. They both have x plus 2. The only thing that I would need to do is I would need to multiply this by x minus 2 on the top and the bottom. Please note that that does not change the value of our right fraction. All we really did was multiply it by 1 because x minus 2 over x minus 2 is 1, but what we did do is we did give them common denominators. And now that we're adding, we're going to have 2x plus 4x minus 8 over our new common denominator. So that would be a total of 6x minus 8 over x plus 2, x minus 2. And I'm done. If you want to factor the top, you're going to get this. But neither one of those things goes, or that doesn't go away with x minus 2. That doesn't simplify or eliminate. So I can be done right here. And that is 10. Last problem. Okay, this concept let's see here, this concept actually is not going to be on the test, so I don't want to give you one more thing to worry about. It is something I would really like to do this year. It is something I will really do this year. But I don't want us to have too many things to think about right now on this one. I want us to be really good at what we know. So we're just going to wrap this video up right there.